Okay. Good evening to everyone. We are pleased to have you all in this evening for this 136th webinar, a weekly online lecture series, Engineers Talk, which is being organized by Institution of Engineers India, Salem Local Center. I would like to invite Engineer S. Loganathan Sir, Chairman, Institution of Engineers India, Salem Local Center, and Council Member, Institution of Engineers India, to welcome the guests and the gathering. Please, sir.
Okay, sir. Thank you, sir. Very good evening to all. We are very happy to again meet you all for the online guest lecture series. So this today is a very important topic. So on the eve of World Environment Day, we are organizing this month environmental friendly concrete, that is eco-friendly concrete lecture. And we wholeheartedly welcome Professor Dr. S. Srinivasa Sambandam, Professor in Annamalai University. We heartily welcome you, sir. And all the members of Salem Local Center, committee members, and our Honorary Secretary, Dr. Sadish Kumar, and all the members, senior members present here, immediate past chairman and honorary secretary, and all the senior members and student members present here. Hope this is a very important topic. Now, doing the concrete become very different. So instead of conventional concrete, we are finding many ways to use different materials in concrete, so that whatever the plastic generated by the human beings, whether it can be mixed in the concrete, whether that this will be suitable for the normal work or road work, or we can use some prefabricated element like that. I think Professor will narrate this important topic. So even though the concrete has been used by more than 200 years, concrete is still important material for the construction. A lot of research is going on every day. So I think the professor has taken the excellent topic. Hope you will all enjoy this online lecture meeting. I request all the members, please be present up to the end of the meeting and interact with the professor. And thank you, sir, for joining with us. And also, I thank our Honorary Secretary, Dr. Sadish Kumar sir, fixing our chief guest today. And have a wonderful evening for everybody. Thank you. Thank you all.
Thank you, sir. Thank you. Thanks for your welcoming address. Now it's my pleasure and privilege to introduce the chief guest and keynote speaker of today, Dr. S. Srinivasa Sambandam, Professor, Department of Civil and Structural Engineering, Annamalai University, Chidambaram. Dr. S. Srinivasa Sambandam started his career in teaching after his diploma in civil engineering. He has been learning continuously while educating students of Polytechnic College and Engineering. He acquired BE in Civil Engineering, ME in Structural Engineering, and obtained PhD in Structural Engineering. He has started his career as lecturer in the year 1985, and by now he is working as professor in Annamalai University, Annamalai Nagar. He has received many awards for his academic achievements. He, he was a gold medalist in ME, the Kalyan Gold Medal for highest marks in ME Structural Engineering, and he has received through C. Meenakshi Sundaram Pillai Prize for first rank in ME Structural Engineering. These are very few to make a note of it. And apart from, he has acquired many awards. He has taken up many research projects as principal investigator and co-investigator. He was appointed as consultant by National Thermal Power Corporation, NTPC, Government of India, for formation of geopolymer concrete roads in the year 2019-2020. He has made a patent registration for two uh, things: dry lean geopolymer concrete mix and method of production, and payment quality geopolymer concrete mix and method of producing the same. And he has published many research publications in international journals, national journals, and he has participated in many international and national conferences. He has guided nearly 11 PhD scholars and 39 ME projects, and he has published nearly 8 papers in national and 53 papers in international journals. He has participated in many staff development program and STTPs, and he has also organized a few, and he has participated in national workshops and organized event. He has delivered nearly more than 30 guest lectures, and he has been in distinguished positions in the university as NSS program officer and faculty coordinator, the Institution of Engineers student chapter of Annamalai University during the period 2024 to 2026. He is member in many professional bodies. He is a life member of Institution of Engineers and life member of Indian Society for Technical Education and life member of Ferro Cement Society India. With these few words of introduction, I would like to invite Dr. S. Thrinjana Sambandam to present on the topic eco-friendly concrete. Over to Dr. S. Thrinjana Sambandam. Please, sir. Sir.
சார் கனெக்ட் ஆகல, ஃபோன் பண்ணி சொல்லுங்களேன்.
யாரு திருஞானம் சம்பந்தம் சார் இருக்காங்க சார்? ஓகே. ஆக்சுவலா அவரு ஸ்கிரீன் தான் டிஸ்பிளேல இருக்கு சார்.
ஆமாமா. போன்ல கூப்பிட சொல்லுங்க.
Yeah. சார் டிஸ்பிளேவும் இல்ல, ஆடியோவும் இல்லையே. Sir, Dr. Thrinjana Sambandam sir, you are not audible. I think you have not started it.
சார் போன்ல பேச முடியலையா?
Sir, evening sir. Actually, sir, secretary sir. Sir,
Sir,
Satish Kumar,
sir,
audio
good evening, sir. He is joining now, sir.
Okay, okay, well.
Issue, sir.
திருஞான சம்பந்தம் சார்.
சார் அதாங்க சார் ஜாயிண்ட் வந்துருச்சுங்க சார். ஆனால் இன்னும் ஸ்க்ரீன் தெரியலங்க சார்.
இல்லை ஒரு மைக் வந்து இன்னும் மியூட்லயே இருக்கு.
மைக்ரோஃபோன் ஆஃப்ல இருக்குங்க சார்.
இஸ் மியூட்டட்.
தெரியுதா?
வரேன்.
இப்ப ஸ்கிரீன் ஷேர் பண்றேன்.
ஓகே ஓகேங்க சார்.
ஸ்கிரீன் வர மாட்டேங்குது விண்டோல.
ஷேர்ல போங்க சார். ஷேர்.
இருங்க, வரலையேப்பா
சார். இல்ல எனக்கு அனுப்பிச்சிடுறீங்களா சார்?
இது ஃபைல் பெருசா இருக்குன்னு பாக்குறேன். ஒரே நிமிஷம் பார்க்கட்டுமா? மெயில் ஐடி எனக்கு அனுப்புங்கப்பா.
இதுக்கு முன்னாடி இனிஷியலா ஷேர் ஆச்சுங்க சார் உங்களுடைய ஸ்கிரீனை. எக்கோ ஃப்ரெண்ட்லி காம்ப்ளீட்னு ஸ்கிரீன்ல வந்ததே.
ஓகே ஓகேங்க சார். ஆனா ஃபர்ஸ்ட் ஷேர் ஆச்சு சார்.
ஷேர் ஆச்சு சார். ஷேர் ஆயிட்டு இருந்தது.
ட்ரை பண்ணி பாருங்க சார்.
ஆல்மோஸ்ட் நான் அவர்கிட்ட செக் பண்றேன். ஜாயின் பண்ணேன்.
Yeah. So now the screen is visible, sir.
Sir, now the screen is visible.
Again, it goes off. Now it's visible, yeah.
Visible, sir.
Yeah. Only thing, he has to speak. Screen is visible, but he got exited, huh? Yeah. Sir, he has to switch
He has
on
to
the
unmute.
speaker mode.
He has to unmute.
Yeah, unmute பண்ணிட்டு he has to speak. Sir, Trinyana Sambandam, sir, you have to unmute your speaker and you have to speak.
இப்போ ஓகேவா?
Yes, sir. Now we are able to hear your voice. And the
Okay.
screen is also visible.
Okay, sir. Thank you, sir. Okay. ஸ்லைட் ஷோ தான் வர மாட்டேங்குது.
Sir, slides also sharing. It's visible. Slides also visible, sir. You are also audible.
Slide இதுல தான் இருக்கு சார் உங்க ஸ்கிரீன்.
ஆ.
Eco-friendly concrete, sustainable construction materials. These are all visible in the screen. So you
But
can go on.
slide show is not.
Oh, slideshow now you want to make it automatic, is it?
Okay, okay, sir.
Yes, sir. Well,
Okay, now it is okay, sir.
Yeah, it's
yes.
okay.
Fine, sir. Sir, let me start, sir.
Yes, sir, please. Yes, sir.
Sir, can I start?
Sir, please. Yes, sir.
Yes,
Okay.
sir, please.
Okay. Thank you, sir. Sorry for the inconvenience. So let me start this echo வருது இதுல eco friendly concrete echo வருது. சார் இப்ப நான் பேசுறது கேக்குதா?
Sir, your voice is okay, but as you have told, with some echo, we are hearing it.
Sir, இப்ப கேக்குதா?
Yes.
Fine, sir. Okay, let me start, sir.
Yes, sir, please.
Sir, first of all, I want to say very sorry to all the participants for the inconvenience happened now. Let me start this topic, eco-friendly concrete. What do you mean by eco-friendly? Actually, concrete is the general term everywhere people are using. It means sustainable construction materials for a greener future. Greener future. So that is the important point. To make green environment, we have to make the concrete. We know very well concrete is the second largest material handled by the mankind. That is second to water. Eco-friendly concrete reduces environmental impact while maintaining the strength and durability. So these 2 points are very, very important. Before seeing the concept of eco-friendly, strength and durability of concrete is the very important criteria we have to see. See, in general, construction contributes significantly to global CO2 emissions and resource consumption. See, let me take the first raw material used in concrete, that is cement. When you produce cement, equivalent amount of carbon dioxide emitted from the cement factories. So that is one of the major point we have to see. As far as possible, we have to minimize the emission of CO2 from the cement factories, or we have to eliminate cement from the concrete. So those things we are going to see in this seminar. Second point, high cement production causes large carbon emissions and energy use. So this is a point we have to make it very clear. As far as possible, we have to reduce the usage of cement by means of using secondary cementitious material such as fly ash, slag, silica fume, and geopolymer binders. What is these ingredients? Fly ash, slag, silica fume, and geopolymer binders. One by one, we are going to see. Fly ash is the byproduct obtained from the thermal power stations. Slag is obtained from the steel industries. Silica fume is also obtained from the steel industries. Geopolymer binder is one of the new material now people are using to make binding property in constituents of concrete without cement. We will see it in brief. Second point is crushed concrete and recycled materials can replace the natural aggregates. So that is the second point. First, we have to eliminate cement. Second, we have to eliminate the or reduce the usage of natural aggregates. That is coarse aggregate as well as fine aggregate. See, initially people are thinking cement is made by cement, fine aggregate, coarse aggregate, and water. So now we have to eliminate one by one from cement, then fine aggregate, then coarse aggregate, and water also. How to eliminate these things from concrete, and we have to make it greener concrete. We will see it in brief. When we use this fly ash in concrete, it improves workability, durability, and reduces waste disposal. This thing everybody knows. Nowadays, people are using fly ash as the partial replacement in cement. In cement production itself, people are using this fly ash, and we are producing it as PPC from OPC. Right. Now, when you use these kind of industrial byproducts, it emits less carbon dioxide than the ordinary Portland cement. Right. Next, how to make greener concrete. So in this case, nowadays people are using bacteria in concrete in capsules form, and if you use this bacteria in concrete at the time of production, it will repair the cracks automatically in due course. So that is one of the point people are making this bacterial concrete nowadays. Right. Then another concrete is pervious concrete. In urban areas, especially in road constructions, the concrete itself allows water infiltration, thereby reduces the urban flooding. That is impervious concrete. Right. When we use these kind of greener concretes, what will happen? What are the advantages and what are the limitations? We have to see in brief. That initially, if you introduce these kind of greener concepts in concrete, it will increase the initial cost and limited awareness. So we have to create awareness among the educationalists as well as industrialists to make it in practice. and sometimes some technical barriers also there. We have to eliminate or reduce the technical barriers. Next, when you use this greener concrete in construction, it can be used in buildings, then road constructions, bridges, and green infrastructure projects, right? So nowadays, everywhere AI is dominating. We have to use these AI-based mixed designs and nanotechnology and advanced carbon neutral materials. So these are all the things are in front of civil engineers nowadays. Next, as far as seeing the policies by the government, some uh, legal forces are required to make the green concepts in buildings, and certification also required for sustainable construction. So this is government side. We need not worry about that. Then, when you use these kind of eco-friendly concrete, we have to make sustainable development and climate protection, right? So this is the introduction about this eco-friendly concrete. Dear participants, can you hear my slides? Can you hear my words and slides moving?
Yes, sir. Yes, sir.
Yes,
Fine.
sir.
நல்ல ஆடியபிளா இருக்கா? கிளியரா கேக்குதா?
Yes, sir. It is very clear, sir.
Very fine. Okay. So let me start the civilization in the world. How the civilization started and developed and developing nowadays. So initially, before Christ, 3,700 years, this is the oldest stone house constructed in Scotland. So this is in the cave houses, குகை வாழ்விடங்கள். That is these caves initially ancient people used for staying in this kind of small constructions. And you can see these underground structures constructed in England. This is also before Christ, 3,650 years. Still it is there. And in India also we can see these Ajanta caves and pyramids before Christ, 3,000 years back. You can see the pyramid, still it is standing. And some Pantheon in Italy. You see the construction year 29 to 19 before Christ period. So this is the dome construction without any cement and other new binding materials. Actually, they used only lime concepts. Right. Now, this is the UK-based lighthouse. I have civil engineer constructed this lighthouse in UK in the year 1759. This is the first world masonry construction. It's a lighthouse. Still, it is standing. So these are all the origins of development of structures. Now we can see the historical evaluation of concrete. In 1824, actually cement invented by Joseph Aston and patented in England. So before that, before Christian era, 500, you can see the Rome civilization and initial ancient pyramids and also. So we need not worry about these old structures. Coming to this invention of cement era in 1824 and introduction of steel in concrete in the year 1903, and slowly development happened in the form of precast construction, that is in the year 1950. In this 20th century, now people are focusing to produce eco-friendly concrete because, as I said earlier, the ingredients in concrete: cement, fine aggregate sand, coarse aggregate jelly, and water. These four components are creating problems in terms of procuring and how to secure these materials with the safe and cost effective. So these are all the things in the historical evaluation of concrete. Now, we can see the development of concrete right from the birth of cement. Actually, this cement developed by Joseph Astin, Mason's son, in the year 1824 in UK. Almost 200 years completed. The cement usage in this construction industry. We know very well in the initial stage we produced only ordinary Portland cement OPC, and nowadays with the introduction of mineral the admixtures as fly ash, we are producing Portland Pozzolana cement PPC. In the case of OPC, we are having different grades 33, 43, 53. But in case of PPC, no grade was awarded in India. And with respect to weight of concrete, we can have four categories. One is lightweight concrete, that is 1200 kg per m cube, and lightweight concrete less than 1800 kg per m cube, and normal weight concrete, that is our conventional cement concrete weighing 2400 kg per m cube, and heavy weight concrete more than 3200 kg per m cube. So this is based on weight: ultra light, light, normal weight, heavy weight. And based on the strength, we can classify the concrete as low strength, that is less than 20 megapascal compressive strength, and moderate concrete 20 to 50, high strength 50 to 200, and ultra high strength more than 200 megapascal. All right. Now we can see the current scenario in production of concrete. Nowadays, everywhere demand increases vastly for raw materials. As we discussed earlier, procurement of cement, fine aggregate sand, and coarse aggregate. Difficult to produce concrete due to continuous fluctuations in availability of raw materials. Frequent hikes in cost prices of the raw materials of concrete due to their inconsistent availability. Then these kind of raw materials are contributing to global warming by using cement as a raw material for concrete. So now we are in need of finding an alternate raw materials for making concrete as eco-friendly. Right. Coming to this concrete in general, why concrete is so popular? Concrete can be fabricated practically anywhere, right? Can be molded and cast into a wide range of shapes and geometry. It is relatively cheap, stronger, and more durable. Versatile material. What do you mean by versatile material? Audience can interact. We can make the session lively. What do you mean by versatile material? யாராவது சொல்லுங்க. Audience.
Sir, we can construct any type of structures through concrete, sir. That's why we call it as a versatile material. Versatile material.
அதனால ஜனரஞ்சகமா சொல்லணும்னு சொன்னா, கமலஹாசன் நடிச்ச படம் சகலகலா வல்லவன், அதான் சரியான மீனிங். காங்கிரீட் வந்து ஒரு சகலகலா வல்லவன். ஓகே. ஸோ வர்சடைல் அப்படின்னா எல்லா திறமையும் உள்ளடக்கி இருக்கணும், அதுதான் காங்கிரீட். ரைட். Coming to technical point of view, it is stronger and more durable. That's very important point. And relatively cheap. What is the concrete cost of concrete per kg? யாராவது சொல்ல முடியுமா? காங்கிரீட் ஒரு கிலோ எவ்வளவு? பிராக்டிசிங் இன்ஜினியர்ஸ் இருக்கீங்களா அதுல? Audience, பிராக்டிசிங் engineers இருந்தா சொல்லுங்க. What is the cost of concrete per m cube? Let us take M20 grade. M20 grade concrete or m cube எவ்வளவு சொல்லுங்க? நான் பேசுறது கேக்குதுங்களா? ஆடியன்ஸ்
சார் ஆடியோ சார்.
சும்மா சொல்லுங்க. ஒரு m cube கான்கிரீட் எவ்வளவு இன்னைக்கு? இப்போ
5000
சார் 4.5 சார் 4.5k. This is M20.
5000 வெச்சுக்குங்க. 5000 வெச்சுக்குங்க. What is the weight of concrete per m cube? கான்கிரீட் நோட weight என்ன சொல்லுங்க ஒரு m cubeக்கு?
Sir 2500 kg to 3000 sir based on the
okay 2500 வெச்சுக்குங்க. So what is the cost of concrete per kg? 5000 by 2500 approximately.
Yes sir, approximately it's around
5000 by 2500
2 rupees.
2 rupees. Right. அதுதான் கான்கிரீட் நோட பிரைஸ் பாத்தீங்கன்னா 2 rupees. இன்னைக்கு வந்து பிரிஞ்சால் கத்திரிக்காய் ஒரு கிலோ எவ்வளவு மார்க்கெட்ல சொல்லுங்க?
around 40 rupees.
40 rupees. நல்ல ஜனரஞ்சமாவே நீங்க பாப்போம். கான்கிரீட் வந்து 2 ரூபாய், கத்திரிக்காய் 40 ரூபாய். So concrete is the cheapest material in the world. Accept பண்ணிக்கிறீங்களா? Yes or no?
Yes sir.
Yes.
Yes sir.
கான்கிரீட் பாத்தீங்கன்னா உலகத்திலேயே cheapest material. ஒரு கிலோ வந்து 2 ரூபாய் அவ்வளவுதான். 2 rupees தான். இதை விட சீப்பஸ்ட் மெட்டீரியல் உலகத்துல கிடையாது. ஆனா நம்ம எப்படி யூஸ் பண்ற கான்கிரீட்டை நல்லா கவனிங்க. somebody use concrete, somebody misuse concrete, somebody abuse concrete. என்ன சொல்லுங்க பாப்போம்? somebody use concrete, misuse concrete, abuse concrete.
Somebody abuse concrete.
நல்ல மீனிங் எடுத்து பாத்தீங்கன்னா உங்களுக்கு வந்து ரொம்ப திங்க் பண்ணி பார்த்தா வந்து உங்களுக்கு நல்ல நிறைய மீனிங் புரியும் உங்களுக்கு. யூஸ், மிஸ்யூஸ், அபியூஸ். இன்னொரு பாயிண்ட் சொல்றேன் உங்களுக்கு. கான்கிரீட் இஸ் தி மோஸ்ட் டெமோக்ராட்டிக் மெட்டீரியல் இன் தி வேர்ல்டு. வாட் யூ மீன் பை டெமோக்ரஸி? India is the biggest democratic country in the world. Yes or no?
Yes sir. Yes sir.
Anybody can become PM or CM. அப்படிதான் உண்மையா பையா?
It's true sir.
உண்மைதான் சார்.
உண்மைதான். அதே மாதிரி கான்கிரீட்டை பொறுத்த வரைக்கும் ஏதாவது ரூல்ஸ் நம்ம ஃபாலோ பண்றோம்னா கிடையாது. Concrete can be made with any proportion, with any material. Nobody is worrying about the proportion as well as the material selection. Government is insisting grade of concrete. What is the minimum grade of concrete required for structural purpose?
M5 sir.
M20. Okay.
M20 sir.
M20 minimum grade required. Nobody is worrying about that. Nobody is worrying. நம்ம ஊர்ல நீங்க கான்கிரீட் போடுறாங்க, ரூஃப் கான்கிரீட், யாராவது M20 கிரேட் டிசைன் பண்ணி போடுறோமா?
No sir.
Which code book is required for getting the mixed proportion of concrete?
IS 10262.
10262.
இன்னும் 124 தான் தெரியுது. 124 தான்
10262. அதான் மிக்ஸ் டிசைனுக்கு நம்ம யூஸ் பண்றோம். யாராவது நம்ம ஊர்ல ஃபாலோ பண்றோமா? நோ,
இல்லைங்க சார்.
நமக்கு தெரிஞ்ச ஒரே மிக்ஸ் வந்து இன்னும் ஸ்டில் M15க்கு இருக்க நாமினல் மிக்ஸ் 1:4. 1:4க்கு பிராக்டிக்கலா என்ன யூஸ் பண்ணுவாங்க ரேஷியோ? மிக்சர் மிஷின்ல போடுற போது 2, 5,
3 சார்.
7. சூப்பரா சொல்றீங்க. 2, 5, 7. இதுதான் வந்து உலகம் பூரா யூஸ் பண்ணக்கூடிய ப்ரொபோர்ஷன். என்ன நம்ம வந்து மிக்ஸ் டிசைன் பத்தி கவலைப்படுறதே இல்லை. பட் M15, M20க்குல தப்பிச்சிருவோம். If you go for higher grade, more than M25, it is very difficult to get the nominal mix proportions. So at that time, we need 1026 to support. Okay? Right.
Yes, sir.
Now coming to this admixtures to concrete. Chemical admixture, mineral admixture. We do not worry about mineral admixture. Nowadays, we are getting the PPC cement. So it includes secondary cementitious material. So automatically we are getting the PPC in addition with the mineral admixtures. Coming to these chemical admixtures, with respect to special concrete, we need some special chemical admixtures. In general, we are using the SP superplasticizer, that is the general chemical admixture. Normally people are using. We need not worry about other chemical admixtures that can be used for special applications. Right. Coming to this quality of concrete. Quality of concrete is very important with respect to durability of concrete. So in that case, several points we have to see, right from water cement ratio. As I said earlier, concrete is the most democratic material in the world. So nobody is worrying about water cement ratio. When you increase water cement ratio, what will happen? Normal water cement ratio we are obtaining from the mix design as per IS 10262. If you add more water, what will happen?
Strength decreases.
Strength decrease. Very good. If you reduce water, what will happen?
Shrinkage.
Slump will affect. Slump will affect. Slump workability will be affected. Correct?
Yes, sir.
Yes. So with respect to IS 10262 mixed proportions and water cement ratio, we have to be doubly careful in selecting the water cement ratio. We will see some slides, technical aspect with respect to water cement ratio. Then sand stone ratio, that is ratio between fine aggregate and coarse aggregate, and cover depth. In general, people are using cover block in slab as well as beams, right? But with respect to exposure conditions, the thickness of cover is getting varied. So we have to be doubly careful in getting the cover. Then chloride content in constituents, especially in water, we have to use the potable water, and moisture content, oxygen. So these two things are required to take care of corrosion in concrete. When you increase this moisture content and oxygen, it is prone to corrosion of reinforcement. Then pH value of concrete. What is the pH value of concrete? Anybody can tell me? Concrete நோட pH value என்ன சொல்லுங்க பாப்போம். Audience, லைன்ல இருக்கீங்களா? சும்மா சொல்லுங்க. What is the pH value of water? Potable water, drinking water.
6.5 to 8.5.
Okay.
For potable water.
Okay. pH value of concrete?
12 to 13, sir.
12 to 13. Okay. Highly alkaline. Very good. So the concrete pH is greater than 13. Greater than 13. Okay. When it reduces, corrosion of reinforcement will take place. So that is the point we have to make it very clear. Okay, so when it is in alkaline side, it is very safe against the corrosion of embedded reinforcement. When the pH value of concrete drops from 13, automatically there will be the initiation of corrosion of reinforcement, right? Then coming to this temperature, what is the apt temperature for concreting, especially for roof concreting? I used to say in my concrete classes, before 7 a.m. and after 7 p.m. Okay? Agree பண்றீங்களா? Before 7 a.m. if you complete your concrete, it is very safe. Otherwise, after 7 p.m. right? What is the advantage
sir.
of this one?
Reduce the shrinkages, sir.
Reduces shrinkage of
Shrinkage.
concrete. Okay, with sunlight more than 35 grade centigrade, what will happen? Evaporation of water from the concrete will take place. Automatically, it reduces the strength from prevention of hydration of concrete. Okay, then electrical resistivity, crack width, type and size of reinforcement bar, permeability of concrete, method and time of curing. So one by one we have to see it elaborately. Due to running short of time, just I am passing these slides. Now we can see the basic material properties. Okay, normally people are concentrating in density of concrete. Suppose if there is 5% voids in concrete, what will happen in strength? You see the note given below this graph. 5% voids can lower the strength by as much as 32%. Okay, 5% voids இருந்து அப்படின்னு வச்சுக்கோங்க, எவ்வளவு ஸ்ட்ரென்த் குறையுது? 32%. ஓகே, அப்போ உங்களுக்கு காம்பாக்ஷன் ஆஃப் காங்கிரீட்டினுடைய இம்பார்ட்டன்ஸ் தெரிஞ்சுக்கலாம் இல்ல. ஓகே, ரைட். நெக்ஸ்ட் வாட்டர் சிமெண்ட் ரேஷியோ 0.4, 0.5, 0.6. Reduce ratios produce concrete strength of 0.95, 0.72 and 0.55 times 28 day strength. நல்ல கவனிங்க, வாட்டர் சிமெண்ட் ரேஷியோ 0.4, 0.5, 0.6. சப்போஸ் 0.6 யூஸ் பண்ணீங்க அப்படின்னா எவ்வளவு பர்சன்டேஜ் ஸ்ட்ரென்த் கிடைக்குது? only 55% strength. How much strength reduced? 45% strength is getting reduced when you increase water cement ratio from 0.4 to 0.6. Right. Another important technical point. If you see the stress strain curve of concrete with the different grades, which test is required to get this stress strain curve of concrete? யாராவது சொல்ல முடியுமா? என்ன டெஸ்ட்ல இந்த கிராஃப் உங்களுக்கு கிடைக்கும்?
Compression test. Compression test.
Compression test. என்ன ஸ்பெசிமென்?
150 mm.
Specimen?
150 mm cube.
No. One more answer. From compression test of concrete specimen, we can get this stress strain curve. What is the specimen shape?
Sir, cylinder.
Cylinder. Very good. Okay. So 150 mm dia and 300 mm height cylinders
Yes,
are
sir.
used to find out this stress strain curvature. Okay. Cylinders can be tested under compression. From that you can get these stress strain curves. Right. You just concentrate in this curve.
Hello. In the lab, only cube strength are there. found out. UTM. In the laboratory, cube strength alone found out in the UTM.
Cube strength. See, in this stress strain curves, you can see this descending path and ascending path. இந்த மாதிரி உங்களுக்கு கர்வ் கிடைக்குமா? டிசெண்டிங் பாத் கர்வ் கிடைச்சிருக்கா உங்களுக்கு? கர்வ் மேலே ஏறி கீழே இறங்குது பாத்தீங்களா? டிசெண்டிங் பாத் கர்வ் கிடைக்குமா உங்களுக்கு? This is possible only in strain controlled UTM actuators.
Okay, I am telling usually laboratory, SM laboratory, you are doing only the cube strength.
Okay. Cube strength வந்து உங்களுக்கு only to find out the FCK value. Compressive strength, you can do this test.
Hey, this is also compressive strength.
To get the stress strain curve, we need cylindrical specimen and that too strain controlled testing machines, UTM required to get these curves.
Agreed.
Okay, fine. So coming to this different grades of concrete curvatures, what is the speciality of this curve? Speciality of curvature parunga. Let us take the bottommost one, that is M10 grade, and M15, M25, M40, M50 like that. Are you able to see these different grades of concrete from this curvature? Okay?
Okay, sir.
Right. See, you just see the x-axis, strain. What is the strain value corresponding to maximum compressive strength of concrete? Strain corresponding to maximum compressive strength of concrete. How much? இங்க பாருங்க, maximum compressive strength
0.002.
What is the value of strain?
0.002.
So this is the answer. 0.002 is the strain value corresponding to any grade of concrete. Okay, this is the wonder in concrete. Concrete nuடைய ultimate compressive strength க்கு corresponding உள்ள strain value வந்து 0.002 for all grade of concrete. Okay, coming to this right hand side, you can see the stress strain curve of steel rod. Three curves are embedded here: FE 250, FE 415, FE 500. Okay, here the Young's modulus value, stress by strain for all grade of steel, is constant 2 into 10 power 5 megapascal, right? But at the same time, what is the modulus of elasticity of concrete in different grades of concrete? Is it constant? No. It is varying with respect to compressive strength FCK. We can get the modulus of elasticity of concrete, that is 5000 into root of FCK approximately, right? EC is varying, but ES is constant for all grade of steel, right? Next, coming to the design strength of concrete, the value of concrete compressive strength obtained from concrete specimen in Indian scenario, British standard is cubical specimen 150 mm, right? From that we are getting the FCK value. and 0.67 FCK, that is reduction of strength 33%. Again, to get the design value of concrete, we are applying partial safety factor of concrete, that is gamma m. What is gamma m for concrete? What is gamma m? Audience? Concrete partial safety factor eவ்வளவு?
Sir, 1.5.
1.5, sir.
1.5. Very good. Right. What is the step down from FCK to 0.67 FCK? 33% reduction is given initially. What is the reason behind it?
Sir,
If you
it is for
see-
safety factor, sir. Safety factor.
Safety factor is gamma m.
Gamma m, sir.
Ah,
Sir, which means that the ultimate strength can be for the concrete is getting reduced. We are using into the design the same for that purpose.
correct. FCK is
The actual FCK,
actual
what we
strength of
use.
cube. Correct. FCK cube strength. What is
Yes, sir,
0.67 FCK? You are reducing 33% strength.
So yes, we are reducing into 0.67 that is as you said 0.3733 no, sir. We are reducing that strength of actual strength of FCK, that is 0.67 FCK, sir.
எதுக்கு ரெடியூஸ் பண்றீங்க? ரீசன் என்ன? சும்மா சொல்லுங்க, ட்ரை பண்ணுங்க.
Sir,
இங்க பக்கத்துல பாருங்க, ஸ்டீலுக்கு எடுத்துங்க. Let us take the steel. What is FY?
Characteristic strength of steel, sir.
Yield strength of steel. Here you are applying 1.15, that is partial safety factor.
For steel, sir.
FI by 1.15, you will get 0.87 FI. Correct?
Yes,
0.87 FI. Correct?
Yes, sir. Yes, sir.
Right. Here, only one step down is taking place. FI to FI by 1.15. 1.15 is partial safety factor. From these figures, what do you understand? The reduction of strength FCK to 0.67 FCK. Again, you are applying partial safety factor, but in steel we are not reducing FI to some other fraction. Then we are applying partial safety factor. No. You see this? You see the size effect of specimen. Size effect of specimen. Nalla gavaniga. Maintaining the same diameter of 150 mm, the strength increases by about 80% as height to diameter ratio is reduced from 2 to 0.5. Nalla gavaniga. Let us take a cylindrical specimen. Cylindrical specimen height எவ்வளவு நம்ம ஸ்டாண்டர்ட் சிலிண்டர் 300 mm.
150 into 300 mm.
Right. 300 mm height, diameter 150. அப்ப ரேஷியோ எவ்வளவுங்க? 300 by 150 எவ்வளவுங்க?
2 sir.
2. இப்போ அந்த ஹைட்ட வந்து 300க்கு பதிலா அப்படியே குறைச்சிட்டே வந்து 75 ஆக்குங்க. நல்ல கவனிங்க. ஹைட் வந்து 300 reduce it to 75 mm. Dia same 150. Now what is the ratio? சொல்லுங்க.
0.5.
0.5. Okay?
0.5.
Right. நல்ல கவனிங்க. 300 mm ஹைட்ட வந்து நீங்க ரெடியூஸ் பண்ணி 75 mm ஹைட்ட கொண்டு வந்துட்டீங்க. இப்ப ரெண்டு ஸ்பெசிமெனையும் டெஸ்ட் பண்ணுங்க. 300 mm ஹைட் இருக்கக்கூடிய ஸ்பெசிமென் டெஸ்ட் பண்ணீங்கன்னா அதுதான் வந்து 100%. 75 mm height 300 reduced to 75 mm. அந்த ஸ்பெசிமெனை கொண்டு டெஸ்ட் பண்ணீங்கன்னா கிடைக்கக்கூடிய வேல்யூ பார்த்தீங்கன்னா only 20%. Strength நல்ல கவனிங்க, strength increases by 80%. இதுல பாருங்க 0.5 வச்சீங்கன்னா மேல 1.8. இப்போ M20 கிரேட் காங்கிரீட் 20, இப்போ 1.8 என்னாச்சு 20 into 1.8 2.36 36 MBA வரும் உங்களுக்கு. நல்லா கவனிங்க, சேம் ஸ்பெசிமென் தான் 300 இருக்கிற போது 20 மெகா பாஸ்கல், அந்த ஹைட்டை வந்து 75 mm வச்சு டெஸ்ட் பண்ணீங்கன்னா 36 MBA வருது. ஹைட்டை குறைக்க குறைக்க you are getting increased value of stress, compressive stress. இந்த பாயிண்ட் புரியுதுங்களா? ஆடியன்ஸ்?
Yes, sir.
ரைட். ஒன் மோர் பாயிண்ட், இந்த பக்கம் பாருங்க, ரைட் ஹேண்ட் சைடு பாருங்க. ஹைட் டயமீட்டர் ரேஷியோ இஸ் கெப்ட் கான்ஸ்டன்ட் as 2, 300 by 150 2. Maintaining the same height to diameter ratio of 2, the strength drops by about 17% as the diameter is increased from 150 mm to 900 mm. நல்லா கவனிங்க, 300 mm height 150 mm டயா, அப்ப வரக்கூடிய ஸ்ட்ரென்த் 100% வச்சுக்கோங்க. நீங்க வந்து டயமீட்டர் வந்து 150க்கு பதிலா இமேஜின் பண்ணுங்க 900 mm ஆக்குங்க. அப்ப ஹைட் எவ்வளவா இருக்கு? ஹைட் எவ்வளவு இருக்கு? ரேஷியோ வந்து 2 தான் இருக்கணும். ஹைட் பை டயமீட்டர் 2 தான். டயமீட்டர் 900னா ஹைட் எவ்வளவு இருக்கு?
0.8 2 to 3 சார்.
நல்லா சொல்லுங்க. ஹைட் பை டயமீட்டர் இஸ் ஈக்குவல் டு 2. டயமீட்டர் 900, ஹைட் எவ்வளவு இருக்கும் அப்போ?
1800 சார்.
1800. நல்லா கவனிங்க, ஹைட் 1800, டயமீட்டர் 900. அந்த ஸ்பெசிமெனை டெஸ்ட் பண்ணீங்கன்னா உங்களுக்கு கம்ப்ரசிவ் ஸ்ட்ரென்த் எவ்வளவு டிராப் ஆகுது? 17% ரெடியூஸ்டு. நல்லா கவனிங்க, 17% ரெடியூஸ் ஆயிடுச்சு. சரியா? 0.83 into FCK தான் உங்களுக்கு கிடைக்கும். இதுக்கு பேர் தான் சைஸ் எஃபெக்ட். இதுக்கு பேர் என்னது?
சைஸ் எஃபெக்ட்.
சைஸ் எஃபெக்ட். நல்லா கவனிங்க. இப்ப திரும்ப இந்த ஸ்லைடுக்கு போறோம். இது உங்களுக்கு வந்து இன்னைக்கு டேக் ஹோம் மெசேஜ். இன்னைக்கு யார் யார் அட்டெண்ட் பண்றீங்களோ அவங்களுக்கு டேக் ஹோம் மெசேஜ் வந்து நல்லா கவனிங்க. as per IS code 456, FCK is compressive strength of cube 150 mm. Next, 33% reduction is taking place to get the compressive strength of concrete in structural component, say beam, column, slab. Are you able to understand my point? கியூபுனுடைய ஸ்ட்ரென்த் வந்து FCK, நம்ம காலத்தில் இருக்கக்கூடிய அதே காங்கிரீட்டினுடைய ஸ்ட்ரென்த் வந்து 0.67 FCK. எவ்வளவு பர்சன்டேஜ் ரெடியூஸ் பண்றோம்? 33% ரெடியூஸ் பண்றோம். ஓகே, ஸ்ட்ரென்த் ஆஃப் காங்கிரீட் இன் ஸ்ட்ரக்சரல் ஷேப், சே பீம் ஆர் காலம் ஆர் ஸ்லாப் காம்பனன்ட் is only 0.67 FCK. இதுக்கு அப்புறம் தான் நீங்க 1.5 அப்ளை பண்ணி you will get 0.67 in FCK by 1.5, that is 0.447 FCK. இதுதான் வந்து டிசைன் ஸ்ட்ரென்த் ஆஃப் காங்கிரீட். ஓகே ஆடியன்ஸ், கமிங் டு திஸ் ஸ்டீல் சைடு. ஸ்டீல் பாத்தீங்கன்னா இங்க வந்து ஃபேக்டரி மேட் ப்ராடக்ட். ஸ்டீல் வந்து உங்களுக்கு 10 mm னா 10 mm தான் யூஸ் பண்ண போறீங்க, 12 mm னா 12 mm தான், ஃபேக்டரியில 12 mm தான், சைட்லயும் 12 mm தான். ஸோ அதனால there is no reduction to take care of size of the specimen. Okay, are you able to understand this point? Clear?
Yes, sir.
Right. So coming to this different type of concrete, quickly I want to wind up this session. See, only pictures we are going to see. There are n number of types available in concrete. Normal strength, that is M20 grade concrete, general. Then plain or ordinary concrete. Plain concrete from M5, M10, people are using for getting the platforms and all. Then RCC, pre-stressed concrete, precast concrete, lightweight concrete, high density concrete, air entrained concrete, ready mixed concrete, polymer concrete. N number of concretes available. Just a simple list is shown here, and let us see one by one. Just only pictures only I want to show you. There is no specific test results and all, right? This is fiber reinforced concrete. We know different kinds of fibers, right? Glass fiber, carbon fiber, basalt fiber, then plastic polypropylene fibers. So what is the need of these fibers in concrete? டக்குன்னு சொல்லுங்க பாப்போம், ஒரே ஒரு பாயிண்ட்.
Reduces the plastic shrinkage, sir.
Increases?
Sir, reduces the plastic shrinkage.
Okay, increases dash.
Increases the
increases shrinkage குறைக்குது. எதை இன்க்ரீஸ் பண்ணுது?
Compression.
Increases the performances.
டக்குன்னு சொல்லுங்க, அடுத்த ஸ்லைடு போயிருவேன் நானு. Reduces shrinkage, increases dash strength. Dash strength.
Compressive strength, sir.
Sometimes it will reduce compressive strength when the dosage is increasing.
Tensile strength.
Very good. Okay. Technically, flexural strength is getting increased when you introduce these kind of fibers in concrete. Okay, steel fiber, glass fiber, there are several fibers are available. Okay, we have to be careful in mixing and proportioning. Right. This is textile reinforced concrete. Nowadays, people are trying these kind of textile fabrics. Okay. I don't know the results, but people are working. Right. So this is lightweight concrete. Okay, concrete is floating in water. The main drawback of concrete is self-weight of concrete. Okay. So now people are producing ultra light by means of autoclave aerated concrete, AAC. Ultra light concrete is producing nowadays. Then this is glass concrete, right? For pavements and walls, people are producing this glass concrete, and the introduction of FRP rebars reduces or eliminates corrosion of reinforcement, right? Then micro concreting is required for repair purpose, right? So in these pictures, jacketing of newly introduced reinforcement with the micro concreting. Then self-compacting concrete, right? The drawback of concrete is compaction, right? To get self-compaction, people are introducing SCC nowadays, right? Then polymer concrete introduced in market. In general, this PCC, PMC are used in case of repair works, right? Then nano concrete. Now people are producing nanoparticles, nanosilica, nanocarbon tubes, and graphene oxides. So these are all the things are added with the concrete to get the nano concrete. the main purpose of introducing these nanoparticles is to get the high strength. Then self-healing concrete, right? When you use some healing bacteria at the time of mixing of concrete, biologically it will produce limestone and it will heal the cracks when the crack initiates in concrete. So automatically the cracks are getting closed. That is called a self-healing concrete. Then another revolution in concrete industry is precast blocks, right? Precast components. Still we are struggling in introducing these kind of precast elements in normal constructions. For special constructions, like Teamage and other leading group of companies are producing this kind of ready-made components, but it is not getting popularized, right? But in due course, we will see a lot of precast concrete building systems, right? And another new concrete is ECC. So this is bendable concrete, right? Concrete can be bent like this, right? And another one is reactive powder concrete. To get the ultra high strength, people are producing this 500 megapascal concrete. In case of high strength bridges and other military operational works, people are introducing this. And another revolution in concrete industry is 3D printing, right? So only in some modules, people are trying to get this kind of 3D blocks and walls, right? Let us have a quick look in geopolymer concrete. Actually, I am working in geopolymer concrete for the past 15 years, right? So this geopolymer concrete is cementless concrete, introduced by Joseph Davidovich in the year 1978 in France, right? Here, cement is completely eliminated. Instead of cement, people are using this fly ash, GGBS, and alkaline solution. So that is the binding material. Apart from this, fine aggregate, coarse aggregate are same. Here, 0% cement. Instead of cement, people are using fly ash, GGBS, and alkaline solution. What is alkaline solution? It is a mixture of sodium or potassium silicate and hydroxide. There is some ratio proportion. With respect to that, we have to mix this to get the alkaline solution. That's all. So from this alkaline solution, you can add fly ash, GGBS with the sand, coarse aggregate. You can get this concrete, geopolymer concrete. The advantage of geopolymer concrete is curing. So initially, people tried this geopolymer concrete with hot curing. With the 24 hours hot curing, we can get the 28 days compressive strength of concrete as obtained from conventional cement concrete. In that case, only people used fly ash. Nowadays, the scenario is getting changed. Introduction of GGBS in geopolymer concrete eliminates this hot curing or steam curing. Very simple sunlight curing, that is called ambient curing, is enough to get the compressive strength of concrete. Even with 24 hours air curing, you can get the strength of concrete as obtained from the conventional cement concrete. So this is the specialty of concrete. In our Annamalai University, we have carried out lot of experiments in our laboratory with respect to testing of RC beams, 3-meter beams. This is geopolymer beam and conventional cement concrete beam, right? We can see the comparison, load carrying capacity. I don't want to go in detail about this results and discussion. You can see the comparison. Okay, how much load carrying capacity in control concrete beam, cement concrete beam, and geopolymer concrete beam, which is giving higher values. Like that, this is railway sleepers. You know very well, these kind of sleepers are being made from PSC, pre-stressed concrete. Here, M60 grade concrete used to get these railway sleepers. Comparison made from cement concrete sleeper and geopolymer concrete sleepers. Like that, several components of GPC elements tested in our lab and compared with conventional ferrocement channel and geopolymer channels. This is dooms. Here also we can have a comparison between ferrocement doom and ferrogeopolymer dooms. This is pipe, right? Conventional ferrocement pipe and ferrogeopolymer pipes. The pipes tested in our lab and the comparison is also given, right? Similarly, we made geopolymer bricks. So in geopolymer bricks, clay is completely eliminated. Fly ash bricks, people are using cement. Here, cement is also completely eliminated. Only the thing is fly ash and GGBS and fine aggregate, that is sand. Mixed with alkaline solution, you can get these geopolymer bricks. The comparison also made, and we proved geopolymer technology is very well adopted in case of concrete as well as bricks.
Sir, what is a mortar? Binding mortar. Mortar?
Which one?
What is a mortar? Cement mortar? Binding.
Binding, as I said earlier, this is only fly ash, GGBS, and alkaline solution. That's all.
Okay.
There is no cement. There is no cement at all. Okay. Curing is only 7 days sunlight curing is enough. No need for water curing. Right. Slowly we introduced into this road construction. Actually, Annamalai University professors, myself and Dr. Anthony Jayashekhar, my guide, appointed as consultant by Government of India in National Thermal Power Corporation, NTPC, to form these geopolymer concrete roads in India. So we made one pilot project in Telangana, in Ramagundam. You can see this road formation using geopolymer technology, 0% cement, right? Here we introduced this GPC in RMC. In RMC, we made this geopolymer concrete. Actually, 2 kilometers road we made here in Ramagundam. We know very well concrete roads are containing 2 layers. One is bottom layer, that is lean concrete, and top layer permanent quality concrete. Bottom is called DLC, dry lean concrete, that is M10 grade, and the top layer is PQC, permanent quality concrete. In this picture, you can see these 2 layers. This left side is DLC, right side is PQC. 2 layers, bottom layer, top layer. Bottom layer M10 grade, top layer M40 grade. So both we made by geopolymer technology, 0% cement, and we obtained a patent for this bottom layer in the year 2004. It is a joint patent obtained by Annamalai University and NTPC. So this is granted by Government of India for 20 years. It was flashed in papers also. And recently, 2 months back, we obtained the patent for top layer of concrete, PQC. So for both layers, Annamalai University and NTPC obtained a 20-year patent for the formation of cementless geopolymer concrete roads. Right? The inventor, Joseph Davidovich, is seen here. We invited Joseph Davidovich to Annamalai University in the year 2009 to organize one international workshop. Only one time Professor Davidovich visited to India, to Annamalai University in the year 2009. From Kashmir to Kanyakumari, academicians, industrialists, scientists attended our workshop and obtained knowledge from Joseph Davidovich. And geopolymer technology is very well adopted in India nowadays. So in that point of view, we must thank Joseph Davidovich for his kind visit to our Annamalai University. This is the last slide I want to show you. By concluding remarks, yesterday we made a foundation to new inventions. Today we are advancing in technology. Tomorrow we are going to reshape the construction industry by greener technology. So with this, I wish to conclude by my lecture. If you have any clarifications and doubts, we can have it now.
I think somebody with name Ragini has raised a inquiry. May we know what is your question, ma'am? You raised your hand. Is there any doubt from anybody else? Okay. Thank you very much, sir. You have given a broad overview of concrete, eco-friendly concrete with the cementless construction methodology. And thank you for your presentation. And I would like to request Dr. R. Satish Kumar, Honorary Secretary, Institution of Engineers India, Salem Local Center, to propose vote of thanks. Please, sir.
So before that, I wish to thank the organizers for giving me this nice opportunity to share some concrete views to the audience gathered by Institution of Engineers. Thank you once again.
Yes.
Welcome,
Thank you,
sir.
sir.
Welcome.
Yes, sir. Yeah, very good evening to respected chief guest and keynote speaker of this program, our chairman, sir, and all the participants of our 136th webinar series of our Institution of Engineers Salem Local Center. At the outset, I am happy to thank our chairman of IEI SLC, Engineers Loganathan, sir, and Engineers Talk Organizing Committee, immediate past chairman Dr. K. Tangaraju, sir, past honorary secretary Dr. C. Davmani madam, Dr. A. Kumaravel, sir, engineer Armugam, sir, engineer INR, sir, and engineer Sindil Kumar for their support in organizing this webinar series. Thank you very much. Now, I am very much grateful to our today's speaker, Dr. S. Trinyana Sambandam, sir, Professor of Civil and Structural Engineering Department of Annamalai University. Sir immediately accepted our request and made this evening wonderful. And also, நீங்க சொன்ன மாதிரி இந்த ஜனரஞ்சகமா கொண்டு போயிட்டீங்க சார். ரொம்ப இன்ட்ராக்டிவா இருந்தது, நல்லா இருந்தது சார். cement concrete patti, even though I belong to I am if not belong to civil engineering, I can easily understand the importance of concrete. இந்த 7 AM முன்னாடி போடணும், 7 PM பின்னாடி போடணும்னு சொன்னீங்க. கான்கிரீட் போடுறதா இருந்தா அந்த மாதிரியான தகவல். அப்புறம் இந்த ஸ்ட்ரென்த் அண்ட் டியூரபிலிட்டி அண்ட் சிமெண்ட்லெஸ் கான்கிரீட் எல்லாமே நியூ ஐடியாவா இருந்தது. அண்ட் வெரி இன்சைட்ஃபுல் ப்ரெசன்டேஷன்ஸ். டெஃபினெட்லி திஸ் டேட்டா be useful for civil engineering researchers. Thank you very much for your valuable time with us, and you made me this evening wonderful and insightful. Thank you very much, sir.
Thank you, sir. Thank you, Anurag.
Yes, sir. Thank you all the participants. Thank you everyone for making this event a fruitful and eventful evening. Thank you everyone. Arumugam sir, as usual, you host this in a great manner. Thank you all.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
All the participants from various institutions. Thank you all. Thank you. Good night.